Alright, today in this section, instead of using the calculator to round our answer to the nearest hundredth, we're actually going to simplify the square roots and leave them in square root forms. To simplify square roots, we're going to look for perfect squares, and how we're going to do that is we're going to make a factor trees. One of the things we're going to do is make the pairs come out on the outside of the square roots, and all the singles will stay underneath the square root. Let's first write down all our perfect squares. A perfect square is something where you say 1 times 1 is 1, so I know the square root of 1 is 1. 2 times 2 is 4, so I know the square root of 4 is 2. 3 times 3 is 9, so I know the answer is 3. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. These are all perfect squares. Looking at my first example, I have the square root of 49. Now I notice that this is a perfect square, so I can go directly to the answer. The answer of square root of 49 is 7. It's actually plus or minus the square root of 7, because a negative times a negative is a positive. In my second example, again I have a perfect square root. So the square root of 36 is 6. It's really plus or minus 6 because it could be a positive 6 or a negative 6. My next problem is not a perfect square, so I need to make a factor tree. There are different factors of 12. I can use 2 and 6 or 4 and 3. I'm just going to use 4 and 3. You will still get the same answer even if you use 2 and 6. So I'm going to break down 4 into 2 times 2, and the 3 does not break down any further. A factor tree means all the numbers are in prime form, meaning the only factors are that number and 1. What we're looking for are pairs. Anything that is a pair comes on the outside of the square root. Anything that is a single stays underneath the square root. Only write the pairs one time on the outside. The singles all get written one time under the square root. This example, I could do 9 times 2 or 6 times 3. I'll just go ahead and do 9 times 2. The square root of 9 is 3 times, the 9 breaks down into 3 times 3. And then I have this 2. Look for pairs. So the 3 comes on the outside. The 2 does not have a pair, so it stays underneath the square root. In the next example, I'll go ahead and use 4 times 6. 4 breaks down into 2 times 2. 6 breaks down into 2 times 3. There are a pair of 2's. The 2 comes on the outside. These 2 do not have a pair, so they stay on the inside and are multiplied together. So my answer is 2 square root of 6.